topic is vector polygonal theorem. So the vector polygonal theorem. Vector polygonal, right? Right. So look at here. That's the next time polygonal vector here. Right. Suppose we need to add two vectors. Suppose we need to add two vectors. So how we add two vectors geometrically? How we add two vectors geometrically? From the vectors that are geometrically add, what is the polygon you use to add two vectors? Vectors they are add करने पर use करें. Method है. वैसा ना तो मैं पर अभी polygon का use करा बहुत abstract है If you need to add two vectors, we draw a triangle to add it. Okay? Make a add triangle. We draw a triangle. Make a triangle like Canada. Make a closing side again the y. Result is given by the closing side of the triangle. P and Q. Right. Suppose we need to add three vectors. Three vectors. P, Q, S. Right. So what is the polygon you need to draw? Not at current. If you need to add two vectors, you need to draw a triangle. Triangle has three sides. Okay, sides are not. So vectors they are sides are not the triangle. The polygon use. So if you need to add three vectors, but the other one, the polygon is one sides here. Four sides here. Okay. Now guess what? One, two, scale then S. The closing side represent the result. If you need to add four vectors, so what is the polygon you need to add? What sides are there? Five sides. Okay. We need to draw a polygon with five sides. So you need to represent these four vectors by magnitude and direction of the sides of the polygon taken in order. So you draw P and then Q, P, Q, S, then T. So closing side will represent the result. Right? Result like that. If you need to add simple n number of vectors, we need to add simple n number of vectors. A3. We need to add simple n number of vectors. Right? So what is the polygon you need to draw? How many sides should be there? N plus 1. Right? Which side represent the resultant? Closing side will be the one who represent the n plus 1 side, right? N done equally resultant. So you can draw A1, මම මේ කැමතිද A1 then A2 A3 like that. So this is the end. This is the end side. So side n plus 1, n plus 1 side represent the result. Make it by result. For vector polygon theorem again, right? If several vectors are represented in their magnitudes and direction by the consecutive sides of a polygon, right? The closing side of the polygon represent the resultant of those vectors. Closing side they can mind, resultant, right? So if you want to add n number of vectors, you need to draw a polygon with size n plus 1. Right? You need to represent those n number of vectors in their magnitude and direction by the side, consecutive sides of the polygon taken in order. Right? Then complete the n plus 1 side. Right? Side n plus 1 will represent the magnitude, resultant. Resultant. Right? So that's what called the vector polygon. Right? I can want to know what vectors polygon. Right? So if you are going to draw a polygon with n plus 1 sides, when you draw the n side, the polygon will complete. What does mean? If you draw the n side, the polygon complete. Yeah, the resultant of that n number of vectors are the length of the n plus 1 side is 0, which means the resultant of the n number of vectors must be 0. Why? That means the resultant is 0. Understood? Right below. Yeah. If several vectors are represented in magnitude and direction by the sides of a polygon taken in order, then the closing side of the polygon, taken in the opposite order, represent the resultant vector. Right. So this is it. So in order to add several vectors, more than 2 vectors, you need to draw a polygon. By representing these vectors from the sides of the polygon in their magnitude and direction. Right. Then the closing side of the polygon taken in opposite order will represent the resultant of these n number of vectors. Right. So this is the polygon මේක මේ මම ස්කේල් එකට නැත්නම් ඒක හරියට මන් එකක් නෙවෙයි. නෝයි අදින එක. නිසා මේක ඩිරෙක්ෂන්ස් ගැන කන්සිඩර් කරන්න එපා. This is only to symbolize the polygonal law. Right. The final A inside is this. So closing side will be the one which gives the result, and the direction of the closing side must be in opposite order. All the arrows are so resultant, the arrow direction of the resultant is opposite in order. Right. So R is equal to sum of all these vectors. Like draw this figure and write the expression. So we can prove this using vector triangle law. You can prove this using vector triangle law. Right? Triangle law එක use කරලා prove කරන්න පුළුවන්. Right? So these are the n number of vectors need to add, and we represent those n number of vectors by the sides of the polygon with n plus 1 sides. Like taken in order. Then the closing side, taken opposite order, will represent the resultant vector. Vectors symbol එක දාන්න. Yeah, it's that. Vectors notation එක දාන්න. So let's see. So how you prove this by using vector triangle law? If I ask you to prove this using vector triangle law, how would you do this? So first we can add these two vectors a1 and a2. The resultant of a1 and a2 is represented by this vector. Suppose it is r1. Resultant of these two is given by r. Then you can add r1 to a3. Right? The resultant is r2. Right? So if there is any vector named a4, then you can add r2 and a4. Resultant is given by this r3. n minus 1 r n minus 1 එකට එනවා. ඔහොම ඇඩ් කරන්න පුළුවන්. අපි හිතමු මේ වෙක්ටර්ස් පහයි තියෙන්නේ. n numbers කෙනෙක් ගන්න එපා වෙක්ටර්ස් පහයි තියෙන්නේ. That's the final. Fifth vector is this. So you can add r3 to a5 in order to get the final vector. Right? R3 to add A5, the final vector is resultant is this R3 plus A5. You know that ekin ඇත්තලා ගන්න පුළුවන් n numbers එකකින් යන්න පුළුවන් මේක. Right? No need to show that how many come to you. ඔයගොල්ලෝකින් ඔක අහන්න ගන්න. Right? But you can derive this expression, this one, the vector polygonal law using triangle law. Only you need to add two vectors at once. A1 plus A2 given by resultant is R1. Then add another vector A3. Resultant is R2. Then add A4 to it. N ගානම add කරන් යන්න. That's all you need to do. Right. So there, then we come to the important part of this lesson. Right. This is very, very important. Resolving vectors. Resolving vectors. A part letter, more than 1,000 times will be used in future. Right? Resolving vectors are very, very useful in mechanics, especially laws of motion. Newton's laws already. You need to resolve forces, reaction forces, weight, tensions. You need to resolve, get the components. Right? And also in gravitational fields, you need to get components of velocities like that. In kinematics, you need this resolving vectors. In projectiles will only components like that. Right? In magnetic field, electrostatics, all those lessons will require this knowledge. How to resolve a vector. Right? So suppose we have a vector. Suppose it is a velocity. So we have velocity to this direction. Suppose it is 100 meters per second velocity, which makes angle 30 with the horizontal. Right? So if we go back to the previous lessons, the previous so we can reduce two vectors into one. We can add two vectors and get one resultant. That means if we have two vectors, resultant is one. Again, you can obtain one vector will give the effect of the two vectors, which is a resultant. So how about the opposite of it? Can a given vector breaks into two vectors? Then vectors using triangle law, if you have given a vector P and vector Q, right? So the addition of the vector P and Q, the resultant is R. Right? So like that, can we about by opposite of them? If you given the vector R, right? So we can represent this vector R from two vectors P and Q. Right? The resolving vector means that, right? So a given vector can be divided into two components. Right? But getting two components of the given single vector is the resolving vectors. එක vector එකක් දුන්නාම එයාගේ components දෙකක් ගන්න එක තමයි a given vector breaks into two vectors. That is the resolving vectors. That is what resolving vectors. එක vector එකකින් vector දෙකක් ගන්න හදන්නේ. Right? So you can represent, you can break this 100 meters per second velocity into two vectors. The one is you can represent a one vector like this. The other one is you can resolve this 100 meters per second vector into two parts. One is this x part, the other one is y. Okay? So we can express the single vector in terms of two vectors, x and y. So that's what called resolving vectors. Right? So what is the x component of this? How we get the x component? This is a right angle triangle. So in order to get x component, what you need to do? You can take the cosine value of this angle. So cos 30 is equal to opposite side over hypotenuse. So x is given by 100 cos 30. And cos 30 is root 3 over 2. So x component is 50 root 3. That is one component of this 100 meters per second vector. Right? So this is considered as horizontal component. This is the horizontal component of this vector. So what is the vertical component? So how do we define this vertical component? Sine 30. Sine 30 is y over 100. So y is 100 sine 30. So it is 100 into half. So 50. So you can express this given 100 meters per second velocity in terms of two perpendicular vectors. One is 50 root 3, the other one is 50. Like if you take a resultant of these two, what is the resultant? How we get the resultant? These two perpendicular. So you can get the x squared plus y squared square root, right? X squared resultant is, this is how we get the resultant, x squared plus y squared square root. X is 50 root 3 square. Y is 50 square. Right? So 50 square is common term. You can get it out from the brackets. We have a root 3 square. Root 3 square is 3. We have here 1. 3 plus 1 is 4. Square root of 50 square is 50. Square root of 4 is 2. 100 is coming. R is 100. So if we get the resultant of these two, the resultant is 100. Components the resolving vectors can ekai, right? So resolving vectors is the expressing a given vector in terms of two vectors. Right? So normally we take those two vectors perpendicular to each other. Right? Most of the occasion we take horizontal direction and vertical. That is not compulsory. It is arbitrary. Right? But for our convenience, we resolve these vectors by taking horizontal and vertical direction as the directions. Right? So that is up to you. Up to the lazy number. That is not compulsory. Right? So if a vector is given with the angle, suppose we have a vector P, the angle is theta. So what is the x component or horizontal component of this vector? Right? So you can draw this. This is the x component. And this is the y component. So can you tell me straight away what is the x component of this vector P in terms of theta? How you write this? In terms of theta, x component is P vector times cos or sine? Cos theta. P cos theta. This one, y component is P sin theta. So what about drawing a line which is equal in length to this side? Right, so I am going to make a parallelogram by keeping this vector P as the diagonal. Or parallelogram vector P as the diagonal. Right? So the length of this side is also equal to length of this one. So you can write the length of this side also equal to p sine theta. මේක මෙයාට equal. නේ? ඒ නිසා මේක ඔයාලට මෙහෙම ලියන්න පුළුවන්. Straight away the vector is p, angle is theta. Then you can get the two components. One is along the x direction, which is equal to p cos theta. The other one along the y direction, which is equal to p sin theta. මේ ගත්ත මේ height එකම තමයි මෙයාගේ තියෙන්නේ. ඒතර මේ පැත්තට one direction එක ගමු it is p sin theta. මං ඉස්සරහ ලියත් එහෙමයි කරන්නේ. මෙන්න මේ side එක අදින්නේ නැහැ. වත්තාක මේ side එක තමයි මෙතනින් අදින්නේ. තේරෙනවද? So it is p sin theta. Right? For another example, අපි හිතමු. Right. Now the angle is given from the above. Particular. Now this is P. So how we get the horizontal component and vertical component of this vector P? How we get it? So one method is, since this is 90, and then you can take this angle as 30. And then the x component is p times sine of cos. If you take the 30 angle, it is cos. X is p cos 30. And y is p sine 30. So if you remember, cos 30 is also equal to sine 60. Sine 60. Cos 30 is equal to sine 60. Then, so you can write this x component in terms of this angle also. If you take this angle 60, this will be the y. This is like the y component. And then, this is the opposite side. The triangle again, method. This is the opposite side. Okay? Opposite side of this angle. The opposite side is the sine only. So you can write this in terms of sine angle, sine 60. P sine 60. Okay? You can write this vertical component in terms of cosine. This is also equal to P cos 60. If we take this angle. So stick වෙන්න බා මොන angle එකද කියන එක හැමතිස්සෙම cosine වෙනවා කියන්නේ. එහෙම කරන්නේ නැහැ. Right? Only matters what is the angle you take. The angle එක ගන්න එකත් එක බලන්න it is the adjacent side to opposite side. බලන්න කියලා බලන්න. හරි? චුට්ටක් අපි එක සදාගෙන අපි ඉස්සරහට යමු කියලා පොඩ්ඩක් දේවල් දින කතා කරන්න. Like topic is resolving vectors. Resolving vectors. But yeah. Resolving a vector means breaking it down into its components along the specific axis. Generally perpendicular axis. Right. Figure given in below. Figure given in below shows how to obtain the components of the given capital P vector, along the horizontal and vertical directions. Horizontal and vertical directions. Right. Vector is P, angle is theta. So this side is given by P cosine theta. This is P sine theta. So same as these two. X component is P cos theta. Y component is P sine theta. Right. Take it. Take it again. You take that. To question number 80. Question number 80. Resolve the following vectors along x and y directions. Like following vectors. Along the direction of the angle cosine. Angle in direction resolve the cosine of that angle. Opposite side is sine. Question number 80. Right? So what are the components of the first one? Right? So angle has taken on from here. And so you can resolve these 2 Newton vector to the horizontal and also to the vertical. Right? So what is the x component of this 2 Newton vector? X component of the yes. So the x component. So you can use a triangle method or either. Right? So angle has taken from this side. Right? Now the angle of 45 doesn't matter because this is 90. This angle also 45 is also 45. So along the x direction, how you complete the triangle? The triangle is complete. So this is the adjacent side. So adjacent side is given by, if the angle is theta, adjacent side is given by cosine value of theta. So this is x component is 2 cos 45. So what is the value of cos 45? 1 over root 2. So 2 divided by root 2. Value is 2 divided by root 2. Take a root 2 value get in it. Value is root 2. Over there again. So 2 can be root 2 times root 2. Divide by root 2. So answer is root 2, which is 1.41. X component is 1.41. Right. Then vertical component is given by the sine value of 45. So y component is 2 sine 45. Doesn't matter, sine of was 45 is 1 over root 2. Same value 1.41. ऐसा make angle को everything करता प्रश्न नया sine of cos. Right. So resolve this second one. මේක තමයි y component එක, this is x component. මොනවද components එක එන්නේ? Second එකේ නගලා. මෙයා y component is it was again what 3 root 3 cos 30. Then 3 root 3 cos 30 में මේ පැත්තට angle එක තියෙන පැත්තට ඒක adjacent side එක තමයි මේ පැත්තට තියෙන angle එකත් එක්ක. So in terms of 30 ලියනවා නම් this must be 3 root 3 cos 30. So either you can write the angle is 60 නේ 3 root 3 sin 60 කියලා ලියන්නත් පුළුවන්. මම මේ angle එක ලියන්නේ 3 root 3 cos 30 is root 3 over 2. Root 3 into root 3 is 3. 3 into 3 is 9. 9 divided by 2 is 4.5. X component is 3 root 3 sin 30. That sin 30 is half. Sin 30 is half. So it is 3 root 3 over 2. Simplify it. 3 root 3 over 2. Analytical करेंगे. Right. Another. Third one. On the 14 plus 30, right? For this side. So values final value component හරියට sign එක කොහොමද කියන එක identify කරගන්න කොහොමද කියන එක බලන්න. ඒක තමයි බලන්න. Sin value එකද angle එක ගන්න cosine value එකද කියන එක ඔයාලට හරියට recognize කරගන්න පුළුවන්ද කියන එක තමයි මට මේකේදී බලන්න ඕනේ. Right. For this one, this vertical component y is 40 plus 60, which is 14 times half, again 14 sin 60. 14 sin 60. X component is 8 root 3 cos 30. Now again 8 root 3 sin 30. 8 root 3 cos 30 is the x component, y component is 8 root 3 sin 30. Right? Sine. Right then, find x component is 5 root 3 cos 45. Then 45 තිබ්බනම් 1 දින්න කොහොමද උගත? sin ගත්තා cosine ගත්තා එකම වැල්යු එකේ එන්නේ. ඒ නිසා ප්‍රශ්නයක් නැහැ. So y component is 5 root 3 sin 45. Then one values ඕනේ 45 කියලා 30 කියලා 60 කියලා. You need that. Final one. Root 3 cos 60 is the x component. Y component is 5 root 3, root 3 sin 60. Root 3 sin 60. Right? What's wrong? Huh? Correct. Right. So now, suppose we have two vectors. Right. So let's take this as seventh one of yeah, seventh one kilogram copy. So find me the algebraic sum of x component and y component of the system. Yeah. Find 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 algebraic sum of x and y components of following system of vectors right. So how we get the algebraic sum of x components, right? Take these two vectors individually, right? So first take these two unit two vectors, a vector, right? These two vectors, get the two vectors, right? Suppose, so this is the coordinate axis, x direction and y direction, right? So this is the two unit two vector. Angle is 30 with the direction of x. Then resolve this vector along the x-axis and along the y-axis. Get the components, right? So this is positive x direction and this is negative x direction. Remember that this is positive y direction, this is negative y direction, right? So what is the x component of this vector 2? Along the x direction, the x component again 2 cos 30. Right. What is the y component? 2 sin 30. Right? So then again draw this second. You can do this in your mind. Right? Make a review this other right? Then I'm second vector. Second vector is unit 4 vector of the 4 vector. Angle is 60. Get the components along the x and y direction. Now x component is 4 cos 60. Is it positive or negative? Positive, because it's along the positive x direction. Y component is positive 4 sin 60. Now tell me what is the algebraic sum of x component of these two vector systems. This one have 2 cos 30 value, positive. This one gives 4 cos 60 positive. You need to substitute values. So I'm going to down here. Then take the y values. This one has 2 sine 30. Right, positive. This one also the same direction, so it is positive. Sine 60. Get the components. Unknown. So do this as a first example. So when you take the algebraic sum, you need to consider the direction also, right? If it is along the positive x direction, component is positive. If it is along the negative x direction, consider yeah, it is negative. Right, so handle. Cos 30 is half. Cos 30 is root 3 over 2 plus 4 cos 60 is half. Plus root 3 final answer. 2 sin 30 is half. 4 sin 60 is root 3 over 2. 1 plus 2 root 3. In the component. Root 3 is 1.73. Right, get the x and y components of this system. X and y. Get the algebraic sum of components of the system here. 8 now. This is 10. This is 8. Angle is 30. We can start the mechanics lesson after this. Now make a resolve. I'm not going to draw separate diagram. I'm going to resolve these vectors in this diagram also, right? Now you got to make it now. Paper 13 paper component take up 10 first side. Now again first 30. So the vertical component take up 10 sine 30. Right. May I resolve the theme? It is 8 cos 30 along the y direction. Again, another component below the 8 sine 30 here. Sine 30. Right. Now take x components from element and make a right. So this 10 cos 30 is along the positive x direction. So this is positive. 10 cos 30 is positive. They are in a positive x direction. What about this 8 cos 30? It is along the negative direction. Negative pattern. So it should be subtract cos 30. So remaining value is 2 cos 30. 2 cos 30 is root 3 over 2. So final answer is root 3. Since this is positive value, so resultant will be along the positive x direction. Right? Then what is the y component? Both the 10 sine 30 and 8 sine 30 is in the same direction. So 10 sine 30 plus 8 sine 30. Total is 18 sine 30. Sine 30 is half. The value is 9. Value is 9. Other. Because good. I'll take that. If you ever do this one, I'm going to meet the class, right? You can go. 15-20 minutes. Right. So, what is the value of x component? The x component value is x minus 2. Right. So we'll begin with we start with here. Now, like forget all other vectors. Only you need to consider this vector 2. It's along the x direction. That means angle made with the x direction is 0. Right? Vector x components right? Angle is 0. So the component, if the angle is theta, component only the x direction is given by 2 cos theta. And theta is 0. Cos 0 is 1. Right? So component is equal to 2. And can you expect the the component equal to vector. There are negative positive x direction full vector. A component given by full vector. So it is 2 plus 2. That's okay. They have x component. Then come to this one. Right? Get the x component of this 4 root 2. X component. So 4 root 2 cos sine. 4 root 2 cos. Is it positive or negative? Positive. 4 root 2 cos 45. Then come to here. 3. This angle is 90. Resolve this vector. Resolve next direction. 3 cos 90. 3 cos 90. Cos 90 is 0. Right? So component of this 3 unit 3 vector along this direction is 0. Again, vector එකක් තියෙනවා නම් මේ vector එක යන perpendicular direction එකට අපි resolve කරොත් එහෙම component is 0. Right? There's no effect from a vector, right? From a certain vector along the direction perpendicular to it. Like if you push a body, we make a push right? It doesn't give an effect along the perpendicular direction. Effect only just horizontal effect. You know that? So we take a vertical DNA, yeah, result of horizontal direction. No component will be. Component is 0. Right. Now come to this one. So what is the x component? The component is 4 cos 30. 4 cos 30 plus or minus is along the negative direction. Minus 4 cos 30. Then come to this one. Component of this 2 root 2 along the positive x direction. A component angle is especially here 30. Now, make a angle. So it is 2 root 3 sine 30. Sine 30. Or you can say this angle is 60. 2 root 3 or 60. It is positive. So 2 root 3 sin 30 y the cos 60. On that. Vectors 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Component half. Now resolve. Now get the sum of the system. Half minus cos 30 is root 3 over 2. 2 root 3. Half. You can make it happen now. 2 plus 4 minus 2 root 3. Again, root 3. 2 plus 4 is 6 minus root 3. 6 minus root 3. Root 3 is 1.73. So answer is 4.27. 4.27. Right, now get y components. Y is done. Well, 2 along the x direction. Angle is 0. Angle is 0. Dropping 2 sine 0. Suppose, 2 Newton. This angle is theta. Right? So what is the component along the y direction? It is 2 sine theta. Right? So if the theta is 0, what is the direction of this vector? Along this direction. Now here theta is 0. Theta 0 type again. And now theta 0. So 2 sine 0 is. So y component of this horizontal vector is 0. Right? Vector full vector horizontal direction is 1. So therefore no y component of this one. X factor X factor y factor component plus. Right? Y component this angle is 45. 4 root 2 sine 45 plus y direction. This angle is 90, so you can write it as 3 sine 90. Sine 90, this angle is 90. Right? 3 sine 90. How it become 90? Because angle is theta, this one is value is 3. So the y component is given by 3 sine theta. So what if theta goes 90? This becomes sine 90. Whether they get 90 for one day. Okay. Angle is 30 for sine 30 to the negative y direction 4 sine 30. May I also resolve that? May I get may factor 2 root 3 cos 30. The sine does not matter cos 30. Sine is positive or negative? Negative. Vertical down. 2 root 2 sine 45 is 1 over root 2. Sine 90 is 1. Sine 30 is half. Minus 2 root 2 cos 30 is root 3 over 2. 4 plus 3 minus 2. Root 3 times root 3 is 3. 3 cancel is 3. 4 minus 2 is 2. The starter is y component for the starter is 2. Yes or no? How are they? How about the Repeat the corner we can repeat this question again now. Then the make a target. Then come done. Yes, why? මේ වෙක්ටර් එකක් තියෙනවා නම් වෙක්ටර් එකේ ඇන්ගල් එක නැතුව එලින්ම අපි ගන්න ඩිරෙක්ෂන් එකට වෙක්ටර් එක තියෙනවා නම් component equal to the magnitude of the vector සම්පූර්ණ වෙක්ටර් එකම පැත්තට තියෙනවා කරලා එයාගේ තුන y component එක නැත්නම් ඒක perpendicular direction component එකක් මේක තියෙන y direction එක නම් යාගේ x component එක එච්චරම තියෙනවා By follow up in homeworks ටික කරගෙන යනකොට මම මේක homeworks වලට මාක් කරගන්න. There is only vectors theory වරයි. මේ කරන් ටික හදලා තියෙන අපිට homework questions ටික වෙච්චේවා. Right, you can do question number 15 16 essay question 15 16 19 and 20. Question number 19 and 20, they ask you to obtain the result. Right? Do not go that further. Result to hand apart. Only you need to take the algebraic sum of x and y components. Next week, we will result right? And x and y components algebraic sum of y. Right? Question number 19 and 20, right? Now you can do the question given in today's paper, right? Edo later online class, other paper is doing. Take it over. Okay, sorry. Other is dental. Dental department. Right? Fourth question. You can do the fourth question, right? So tomorrow will be your online class, 9:50. Right, daily note paper 8 and today's paper will be discussed. So many be prepared. Right, so next week we are going to start micro. So screw principle, micro screw gauge. Micro screw gauge එක ගැන කතා කරනවා. Vectors වල චුඩි උඩ තියෙන ගණන් ටික ඒ ටික හදලා ඉවර කරනවා. Right. So vectors ඉවරයි. Vectors වලින් මේක theory ඉවරයි. ගණන් ටික හදලා තියෙන්නේ. ඊට පස්සේ අපි අද third week එකේදී මේක first week, second, third week වල second start කරනවා. Mathematics start කරමු third week එකේ. Right, Lena? Good night.